Hello everyone, welcome to this video. I'm Wang Shiwei, a PhD student studying in Shanghai Jiao University, and I'm very glad here today to introduce you about our research, multiphysics analysis and protection strategy for spatiotemporal corrosion of LBE in lead-based fast reactors. As we know, in lead-based fast reactors, the corrosion of LBE is a big issue, for the cladding could dissolve in LBE, and the mechanical degeneration will caused by the LBE corrosion. After years of research, scientists found that by introducing the oxygen into the LBE, it can form a protective oxide on the cladding surface. But in experiment, we found at low oxygen concentration, the dissolved corrosion is still there. At high oxygen concentration, the high oxidation corrosion will cause very thick oxide layer, and the oxide layer will cause the cladding heat transfer degeneration, and thus influence the deformation and gas pressure. These influences in turn will change the corrosion mode of the cladding. Last time I raised these concerns, says in a conference, this expert says if the oxygen concentration too high or too low is both bad, then what's the best oxygen concentration and why? At that time, I had no idea, but after years of research, we tried to establish the optimal oxygen control strategy. To achieve that, we need to overcome two questions. One, what's the optimal? Two, what's the strategy? For the first question, we established a multiphysical coupled field performance analysis model, to fully understand how the LBE corrosion influences the field performance. In we got mainly three modules, including LBE flow side calculation, cladding corrosion, and field performance. The all three modules are calculated iteratively. To validate the accuracy of we're using the experimental data and the simulation data from the FMX XQ1. The result says the prediction error of is up to 3%, so it's in a good accuracy. We tried using to predict the oxide layer thickness distribution on the different oxygen concentration. The result says no matter how high or how low the oxygen concentration is, there will always be an axial non-uniformity in the oxide layer thickness. That is because the cladding temperature itself has an axial distribution. And we found when the oxygen concentration is very low, there will be a shift in the highest oxide layer thickness. And this shift will cause the peak temperature of cladding to shift, and the shift in the cladding peak strain. Thus, in turn, this will totally change the failure model of the cladding. Through the we can know that the optimal concentration could be the oxygen concentration with the biggest safety margin of the field performance. And thus, we come to the second question, strategy. We tried using the to establish a strategy, but it's very time-consuming. So we try to establish a circuit model to stand for the By using the Kriging and K-in, we establish a high fidelity and high accuracy model K2K. In K2K training, we use the data points generated by and train the K2K to generate more dense predictions. Using dense predictions, we can identify and localize all the kind of cladding failure modes, and thus find the optimal oxygen concentration for different operating conditions, and finally formulate the strategy. Through the prediction results of the K2K, we identify three main failure modes in the design domain, including the oxidation protection failure, the cladding overheating, and the cladding thickness failure. By checking the optimal oxygen concentration in the control strategy, we found that even though the oxygen concentration range is changing frequently in the different design domain, but the optimal oxygen concentration changes very subtle. It's almost keep in the 10 to the negative 6.3. So in the real reactor operating conditions, we can keep the oxygen concentration in that level. Thus, we can diminish the operation we need to keep the reactor safer operation. And finally, I want to give thanks to the Generation 4 International Forum and my research group for this opportunity. And thanks for watching this video.